Have you ever looked at some totally normal, everyday object and just thought, you know what, I could make that smarter? Well, today we're going to do just that. We're diving into the code that turns one of the most boring things in any room, the Humbly trash can, into something actually intelligent. I mean, just think about it. What if your trash can wasn't just this bucket you dump stuff into? What if it could actually keep an eye on itself and give you a heads up when it needs to be emptied? That is the exact problem this clever bit of code sets out to solve. So first, let's talk about the why behind all this. It all starts with a problem that is, let's be real, universal, and just a little bit infuriating. Oh yeah, you know the feeling. You go to throw one little thing away, and you're greeted by a literal mountain of garbage spilling over the top. It's that classic situation where everyone just kind of assumes someone else is going to deal with it. This project says, hey, let's stop assuming and start automating. Okay, so to solve this, you're going to need a few key things. And this isn't just about the physical hardware, it's about the software, the brains of the operation. So let's take a look at the toolkit that makes this bin so smart. All right, here are the core components. You've got the ESP32, that's the tiny but powerful brain running the whole show. For it to know how full the bin is, it uses an ultrasonic sensor. You can think of that as its eyes. Then, to report back what it sees, it uses its built-in Wi-Fi. That's the messenger. And the glue holding it all together? The rules of the game, written in a simple C++ program that tells it exactly what to do. And this part is really fascinating. This is basically the system's control panel, and it's all defined right in the code. The creator says, okay, the bin is 10 centimeters deep, and they decide that full officially means 80%. They even set these custom warning and reset levels. This is where all the smart behavior really begins. So we have the parts, and we have the rules, but how does the bin actually know how full it is? Well, the magic is all in how it uses sound to see. Let's break down exactly how that works. The real hero here is this little device, an ultrasonic sensor. The easiest way to think about it is like a bat using echolocation. It sends out a really quick, high-frequency sound pulse. We can't even hear it, and then it just listens for that sound to bounce off whatever's in front of it, in this case, the top of the garbage pile, and come back. And this shows the whole process, which is actually super elegant. The code tells one little pin, send the ping. Then it tells another pin, okay, now you listen for the echo. Based on how long that little round trip took, it calculates the distance to the trash. But then it does the clever bit. It does some quick math to flip that number around and figure out the percentage of how full the bin is. It's simple, but it works perfectly. Now, those measurements are constantly being checked against the thresholds we saw earlier. As soon as the trash level crosses 45%, a dashboard somewhere might show a filling up warning. But the real action, the main event, happens when it crosses that critical 80% line. And this is the system's whole reason for being. It's not just about sitting there collecting data, it's about taking action when it matters most. This is the trigger point. The second that fill percentage hits 80, a whole different part of the code gets activated. The system instantly switches from being a passive monitor to an active messenger. And it doesn't just send a casual note. Look at this email subject line. It literally yells urgent, it tells you the exact problem, and it even includes a specific project ID. There's absolutely no way to misunderstand this message. And who gets this urgent alert? Not just one person who might miss it. No, the code is set up to email an entire team, 7 different people. It's all about sharing the responsibility and making sure someone sees it and deals with it fast. Okay, so sending an email is pretty clever. But what makes the system truly smart is what it doesn't do. It's designed to avoid being annoying, and that's all thanks to one very simple but very powerful piece of logic. This is such an important question to ask. If the bin is sitting there at, say, 81% full, the code is checking the level over and over again. Without some kind of break, it would just spam everyone's inbox until the bin got empty. So how does it stop that from happening? The solution is this brilliant little thing called a flag. In this case, it's a variable called email sent. The best way to think of it is like a digital sticky note. The moment the system sends its first email, it basically slaps a sticky note on itself that says, hey, I already sent the alert. And this breaks that logic down perfectly. The system will only send an email if 2 things are true. The bin is more than 80% full, and that digital sticky note is not there yet. As soon as it sends that one email, it puts the sticky note on, which locks the alert system. No more emails. Then, the clever part, It just waits for someone to empty the bin. The system only unlocks itself and removes that sticky note once the trash level drops below 50%. This means someone has to empty out a good chunk of it. Only then does the code flip that flag back, and the system is armed and ready for the next time it fills up. And that's really the heart of it all. The hardware is simple stuff. The real intelligence, the genius, is all in the software. This isn't just a sensor screaming data into the void. It's a thoughtful communication system designed from the ground up to be helpful, not a nuisance. It alerts you once, then it patiently waits for the problem to be solved. So, by looking at this code, we've seen how a few cheap components and some really thoughtful logic can solve a genuine, real-world annoyance. It proves that with a bit of creativity, you can add a layer of intelligence to almost anything. So, it just leaves us with one last question. What everyday object will you make smart next?